Dear kids, we are now moving into the subject as told earlier, and this mathematics is getting more interested after you see the 6th standard syllabus. We are going to have our system of teaching, not just by sitting in the benches, and I don't want you to feel you are in a classroom. You should have a free access to the environment, and you should feel at home when you want to learn and prepare. For that purpose, I have chosen to take the class by sitting on the floor so that we will have the oneness of mind. All are equal before each other. And there is another reason also. So when you are crisscross your legs, you should have your blood circulation flow throughout your body. This is also scientifically known, and by sitting like this, you will also have the same effect on your body. So since childhood, if you are able to practice sitting on the floor, you are having a good healthy legs, healthy body, and your healthy life also. You are seeing me sitting on the floor, as I told you, crisscrossed my legs. You see, the effect, as I explained to you earlier, can be much more made easier to understand by the following examples. We used to have the energy passed through the right side, and this side is normally called the sun, S-U-N, sun, Suryan. And the left leg represents the moon, Chandra. Why we refer these two? The sun is the energy point, and the relaxation point is taken care of by the moon. So when you need relaxation, you can put on your left leg, that is moon, represented, on over the right leg, and the energy when required, you can have your right leg passed over the left leg. So that is how, by sitting on the floor, you can have these hygienic habits develop, which is taught to us by our elders, so which will be useful to you. Even at this age, I am able to sit down on the floor teaching to you. This is nothing but practice at our earlier days. You may be also doing it for your future unfailed healthy life. Okay, we are now moving on to the subject, and first of all, we will see that how the chapter on integers is divided, split into sub letters.
Subdivisions. ಅದು ಸೊಲ್ಲೆ.
It is divided into subdivisions, chapter wise. So now we are seeing this first chapter starting with integers, which is subdivided into so many other classifications. To start with, I will just go through these subdivisions. I will just read out the subdivisions, what we are going to learn under this chapter. After seeing that, we will go chapter by chapter, rather the subdivision wise, so that each subdivisions will be clarified to you in detail to have a perfect, clear understanding of the subject. You just see the subject-wise subdivisions are as follows. First we go with additive inverse. I will read out first and start explaining the subdivisions easily to make it understood by you. First we start with additive inverse, and secondly it is properties of addition and subtraction, which is further subdivided into closure under addition, closure under subtraction, and commutative property, associative property, additive identity. So these are all taught under the second divisions. The next one comes as multiplication of integers, under which you can see multiplication of a positive and a negative integer, multiplication of two negative integers, and product of three or more negative integers. These are all explained in this subject, so that you will be having a clear-cut understanding of the subject. The next follows with the properties of multiplication of integers, which is explaining closure under multiplication, commutativity of multiplication, multiplication by zero, and multiplication by identity. Next comes associativity for multiplication, distributive property of making multiplication easier. So next and the last probably will be division of integers, under which the properties of divisions of integers will take you to complete this particular chapter and a more knowledgeable subject for integers under this particular class syllabus. Now we can move on to the subject subdivision wise and subdivision wise. Thank you. We will proceed. After seeing this multiplication of integers, other properties under this multiplication are closure under multiplication. What is that meant? When two numbers are there, so minus 20 into minus 5, as we have already seen, two multiplication signs are there. That is an even number. So the answer will be 100. So this is a closure under multiplication. Then we are seeing this commutativity of multiplication. The addition, when we see the addition, how these numbers are interchanged within themselves. Similarly, here also under the multiplication procedure, the same method is worked out. For example, when 3 into minus 4 is equal to minus 12, because only one odd number minus is there, so minus 12. It can be written as minus 4 into 3. This minus sign, instead of changing the number there, the sign will be changed to the other number. This is the commutativity of multiplication under the integers. So 3 into minus 4, 3 multiplied by minus 4 can also be written as minus 3 multiplied by 4. The result is unchanged. this is called the commutativity of multiplication.
Commutativity இல்ல
Commutativity of multiplication.
ஒழுங்கா சொல்லு விமத்தத்தை பேர சொல்றது.
Then multiplication by 0. We already saw any number multiplied by 0, the result will be 0 always. So this is the multiplication by 0. For example, 0 into 3, answer is 3. Answer is 0. I mean, so 0 into minus 4, again whatever sign it has, the number has, the integer has, the result will be 0 only. So this is the multiplication by 0. So the multiplication by 0, you are able to understand that. Now, what is called multiplicative identity? This is how we have seen minus 3 into 1 will be minus 3. 1 into 5 is equal to 5 because both are positive signs, plus signs. 1 into minus 6 is equal to minus 6. So this is how the multiplicative identities are seen. So in general, when we put it a into 1, which is equal to a, or on the reverse, when you say 1 into a will be also be a. So this is classified under the same rule. Next comes the associativity for multiplication. The same thing as we have seen for addition. There 2 into 3 into 5, when you multiply 2 into 3 and then again by 5, or 2 into 3 into 5, that group sum can also be adopted here in the multiplication. So minus 3 into minus 2 into 5, which can be written as minus 3 into minus 2 into 5. So the answer will not be changed, and this property is called associativity of multiplication. Then distributive property. What is a distributive property? This is also you have seen. Suppose in the foregoing example we saw 2 minus 2 into 3 plus 5. Let us put 3 plus 5 and under the brackets, within brackets. 2 minus 2 into 3 plus 5. The answer will be minus 2 into 3 plus 5 will be 8. Minus 2 into 8 will be minus 16. But this is a distributive property. How it can be written? Minus 2 into minus 3, one group, and minus 2 into 5. What's the answer? Minus 2 into 3 is 6, minus 6, and minus 2 into 5 is minus 10. The total comes to minus 6 plus minus 10, which is equal to minus 16. So this is called the distributive property of the multiplication. As you have learned under the addition, deletion and subtraction, these are the things for multiplication also. You are going to be very careful in applying your minus sign or a positive sign, especially on the minus sign. We are slowly going towards the end of the chapter. We are going to see that division of integers. All along we are seeing addition, subtraction and multiplication. We are yet to touch on integers division. Now here we are going to deal with division of integers. Suppose 3 into 5 is equal to 15. 3 and 5 are integers, and the divisional property can be used in the reverse. 15 is divided by 5 will give you the answer 3. So this is the division of integers. each multiplication of the whole number, there can be two division statements. So when you say 4 into 3 is equal to 12, 12 can be divided by 3, giving you the answer as 4. This is how the division of integers are worked out. I think you can be now thorough with the chapter on integers, which is to start with as the beginning chapter. As a beginning chapter, we are taking you the topic of this integers as the revision of 6th standard. Yes, we are seeing this additive inverse. What is additive inverse? Think that there is a number, a whole number. Say for example 6. When you make 6 as minus 6, then that is called additive inverse. And when you see minus 6, you make it 6, that is called additive inverse. So when you put a negative sign before a number, when it is positive, this is called an additive inverse. So it's very easily understood. A number which is put a negative sign before the number becomes additive inverse. So we will now move on to the next topic, closure under addition. What is this closure under addition? Again, if two numbers are given, say for example 15 and 25, which is equal to what? 40. 15 plus 25 is equal to 40. And this again is a whole number, a positive. Two positive numbers give you a result of a positive number, a whole number positive. So this is an integer. Similarly, two negative numbers, minus 10, minus 20. The total will be minus 30. Even though the minus sign is there, it is also a whole number which is also an integer. Therefore, this is also called the closure under addition and subtraction. We have already seen in our earlier class what is a commutative property. You can write two numbers, say 1 and 3. Say it is 1 plus 3. 1 plus 3, the answer is 4. You can also write the same as 3 plus 1. The answer will never change if the answer is once again 4. Whether it is 1 plus 3 or 3 plus 1, the answer is, the total is 4 only. So this is called the commutative property. Even by interchanging the numbers within themselves, the property will not change. The property in the sense the additional quality will not change. Therefore, this property is called commutative property. So how we can say that? In general, A plus B, where A and B are numbers, A plus B will be equal to B plus A. However, changes you are made, it is one and the same. Next comes, these are all already seen in our 6th standard. Still, it is only a revision of the previous syllabus to make you facilitate with your current syllabus. This is taken care of and it is only a revision for you. Now we are seeing associative property. What is this associative property? Once again you see the numbers 1 plus 2 plus 3. You can see 1 plus 2 within brackets and 3 is another number. So 1 plus 2 grouped together and 3 is another. The answer will be 3 plus 3 is equal to 6. You can regroup it in another way. 1 plus 2 plus 3. 2 plus 3 within brackets. So what will be? 1 plus 2 plus 3 is 5. 1 plus 5 is equal to 6. The answer never gets changed. Total never gets changed. So it is unchanged. This property of changing between numbers by getting the unchanged result is called the commutative associative property. This is also explained earlier through the line diagram. Then another property was additive property, additive identity. We put it like this. What is this additive identity? When we have 0, a number, and which is added to another number, the total remains same. 0 has no value there, but it is a number. Therefore, 5 plus 0 is equal to 5. 0 plus 5 is equal to 5. So this is called additive identity, where your whole number is 0 is an additive identity for this whole numbers. Now we are moving from additive to the text system of calculations, that is multiplication, division, etc. Now we are going to see about the multiplication of integers. As we saw the addition and the subtraction, it is also the multiplication here. What is that? 5 plus 5 plus 5. 3 times 5. How you can write it? 3 into 5. 5 is 3 times. So 3 times 5 can be written as 3 into 5. The result shows as 15. So 5 plus 5 plus 5. The additive capacity of 3 5s will be equal to 15. It is given as a multiplication sign, that is 3 times the 5 is also equal to 15. So this is the multiplication of integers. Then this is for a positive and negative numbers also. What will happen if positive numbers are multiplied and the negative integers are multiplied? Suppose, as I told you, 5 plus 5 is equal to 25. 5 minus 5 into minus 5 is also 25, because two negative signs when multiplied goes on to give you the positive sign. You simply multiply the numbers and put a positive sign. Two negatives are removed and put a positive sign plus. So two negatives makes the number positive. Whereas if you have three numbers, minus 2 into minus 2 into minus 2, the answers will be 8. 2 into 2 into 2 is 2 into 2 4, 4 into 2 8. So the answer will be, the result will be minus 8, because it is the third time. This is an odd numbers. So when negatives are used in multiplication in even times, that is 2, 4, 6, something like that, you have to put a positive sign. When it is used in the multiplication in odd times, that is 3, 1, 3 times, 5 times, 7 times, etc., the sign will remain same, that is minus sign will remain, and the product to be preceded by a sign minus. What will happen if 1 minus 1, 1 plus is there? Minus 2 into plus 2. Again, because 1 minus is there, the answer will be minus 4. So wherever the minus occurs in odd times, the answer will be minus only. Whereas when the negative sign appears even times, the answer will be in positive signs. So this is how the multiplication of a positive and a negative integer are worked out, and 2 or more negative numbers are also worked out. I think it's clear to you. You are able to understand it? Very good. Very good. And say, whatever I teach you, you can see this, you can get all these things and your exercises worked out in the description box below. Things are given in that. So you can very easily see that exercises worked out there. So we will go on to the next chapter slowly, step by step, for the knowledge of other topics. We will meet you. Thank you. Good luck.